Away from that, we have seen how to make some calculations. We are still going to proceed. Let's proceed now to the next type of calculation in stoichiometry. And that is calculations that involves mass, volume, and mole. Calculations involving mass, volume, and mole. So, let us take a look at the first example. The question says, we should calculate the volume of dry oxygen gas measured at STP, which will be produced from the decomposition of 2.45 grams of potassium triisochlorate 5, KClO3. And we are given the atomic masses in bracket. What volume of dry oxygen gas? That's the question. We have to calculate the volume of dry oxygen gas at STP that will be produced from potassium triisochlorate 5. And potassium triisochlorate 5 provided is 2.45 grams. So simply put, what is the equation first? The equation of the reaction is provided for us. So potassium chlorate 5 was provided and it was decomposed and it gave us products. So we are simply going to calculate the volume of oxygen gas that is being produced. So look at the subtopic, calculations involving mass, volume, and mole. So it means we are going to be interchanging between mole, mass, volume, mole, mass, volume, mole, mass, volume. That is actually what we are to do here. So looking at that, let us proceed. We're going to solve series of equations, looking at series of equations and questions. And I believe by the time we are done, you will be so equipped and you will really desire to do these calculations over and over again. KCl plus, okay, let's make that clear. We have so we have KCl plus O2. So the next step to carry on is to check for the balanced equation. Is the equation balanced? That's the question. We are provided with 2.45 grams. 2.45 grams of this compound. And the compound was decomposed by heating. And as it was heated, it produces KCl and oxygen. So the next thing to do is to check if it is balanced. Potassium at the left is 1, chlorine is 1. Oxygen at the left is 3, oxygen at the right is 2. So oxygen is not balanced. So everyone ought to be balanced. Now how do we balance that equation? To balance the equation, we simply have to say, let's see how to make oxygen balance both right and left. And that will make us to attempt placing 2 here and 2 here. Potassium is 2, chlorine is 2, oxygen is 6, and oxygen will now be 3 here. So that makes it 6. So this is a balanced equation. And the question says, what volume of oxygen will be produced from decomposing that compound? So we are interested in the volume of oxygen. Now, to solve this type of questions, we need to ask ourselves first, how many moles of potassium chlorate is there? And how many moles of oxygen do we also have there? From the equation balance now, we have 2 moles of potassium chlorate. And 2 moles of potassium chlorate produces 3 moles of oxygen gas. 2 moles of potassium chlorate produces 3 moles of oxygen gas. And we are interested in oxygen because the question says we should calculate the volume of dry oxygen that will be produced when 2.45 grams of that compound is decomposed. So, looking at what we have, 2 moles of potassium chlorate produces 3 moles of oxygen gas. So, having seen that 1 mole of any gas, 1 mole of a gas occupies 22.4 dm cube in volume. Let us now proceed with that standard. Our question says, what volume of dry oxygen gas will be produced when 2.45 grams of potassium chlorate is decomposed? From the equation, we need to understand how many volume of oxygen is produced from what we have in potassium chlorate. Then we can now relate it to, if we have 2.45 grams of potassium chlorate, what volume of oxygen gas will it give us? So from the balanced equation, 2 moles of potassium chlorate produces 3 moles of oxygen gas. So we need to know the mass of potassium chlorate, that is this potassium chlorate. We need to know the mass of potassium chlorate that is giving us these moles of oxygen gas. We don't need to calculate the mass of oxygen because what we are dealing with here is volume. Now, mass and volume. We are dealing with mass to volume. Can you see that? Not mass to mass. So this time around, we don't need the mass of oxygen. We actually desire to calculate the volume of oxygen, not its mass. So we are dealing with mass to volume, not mass to mass. So we need to know now what mass of potassium chlorate produces a given volume of oxygen, as we can see. So to calculate the mass of potassium chlorate now, we have 2 into potassium is 39. We have chlorine is 35.5, oxygen is 16. So we have 39 plus, let's undo this. So we have, here we have 39 plus 35.5 plus oxygen is 16, but there are 3 there. We have 16 times 3, and that gives us 2 into. So against oxygen, we have 3 volumes of oxygen gas produced. If 1 mole of a gas will give us 22.4 dm cube, then 3 moles will give how many volume? Look at it. This is from the equation. We have 3 volumes of oxygen. So it means if 1 mole, that is 1 mole of a gas, occupies 22.4 dm cube, then it means that 3 moles of oxygen will be 3 times 22.4. So from the equation, oxygen is occupying 3 times 22.4 dm cube. So that is what it implies. Now here we have 2 into 39 plus 35.5 plus 48. So when we do the summation, 39 plus 35.5 plus 48, now that gives us 3 times 22.4. It gives us 67.2. 3 times 22.4, it gives us 67.2. So when we do the summation of 39 plus 35.5 plus 48, it gives us 2 into, that will give us 122.5. That is against 67.2. So 122.5 times 2 will give us 245. So what it means is 245 grams of potassium chlorate produces 67.2 dm cube of oxygen gas according to the equation. According to the equation, 245 grams of potassium chlorate produces 67.2 dm cube of oxygen gas according to the equation, because it is confirmed, we have confirmed that 1 mole of a gas will give 22.4 dm cube. And from the equation, we have 3 moles of oxygen gas. And since we have 3 moles of oxygen gas, it means that that volume is 67.2 because we're going to multiply 22.4. So from the equation, it is proven that 245 grams of potassium chlorate produces 67.2 grams or 67.2 dm cube of oxygen gas. That is the volume of oxygen gas produced according to the equation. But the question now is, if 2.45 grams is provided, so if we have 2.45 grams, that is the question. 2.45 grams of potassium chlorate is provided. What volume of oxygen gas will it give? That is the question now. So if 2.45 grams of potassium chlorate is provided, what volume of oxygen gas will it give? That is what our question is. So let us take a look at how to solve that. Now, we are simply going to go cross-multiplying. And we'll cross-multiply. We're going to have 245 grams times x. That is what we're going to have. So we have it as 245 times x equal to 67.2 times 2.45. So 2.45 times 67 times x, 2.45 times x will give us 2.45x equals 67.2 times 2.45 gives us 164.64. So what do we do next? Divide both sides by 245. 245. So when we do that, 245 can take care of 245. Therefore, x is equal to 164.64 divide 245 will give us 0.672 dm cube. So that is our answer. So the volume of oxygen that will be produced when 2.45 grams of potassium chlorate is provided is 0.672 dm cube. Now, sometimes in a given question, you may be told to leave your answer in cm cube. If you are told to leave your answer in cm cube, you simply multiply by 1000. That is to say, if we are converting dm cube to cm cube, you simply multiply by 1000. So multiplying by 1000, that gives us we're simply going to take the decimal point 3 places. So multiplying by 1000, we have 1, 2, 3. 1, 2, 3. So it means our x will be 672 cm cube. And that is it. So if you're told to convert your dm cube to cm cube, you simply multiply by 1000, and then multiplying by 1000, we move our decimal places 3 places, and we take away 3 zeros, and we have 672 cm cube. So either in cm cube or in dm cube, your answer is correct. So let us take a look at what we just solved. So this is actually our answer. So we can see, balancing the equation, we have 2 moles of potassium chlorate giving us 3 moles of oxygen gas. And for that reason, we recall that 1 mole of any gas at STP is occupying 22.4 dm cube is a constant. And for that reason, we have 245 grams giving us 3 times 22.4 dm cube. When we cross multiply, we have 0.672 dm cube or 672 cm cube. So that is actually how to calculate this type of questions that involves mass, volume, and mole. That is actually how to do such kind of calculation.